going to need your answer sheet out. We're going to gather our information that we got and see if that tells us anything significant about the health of that stream down there. Yesterday's weather. Does anybody remember what that was?
Gross.
Suppose we had Hurricane Irene and buckets of rain coursing through this area. Would that impact our results?
Absolutely.
Suppose we had middle of August, middle of a drought for 60 days and it was 90 degrees outside. Would that possibly affect our results? Okay. So this weather stuff is important stuff to pay attention to and record. How about our water temperature? Oh, we got 78.
Okay. 68?
68.
70.
70. Anything else?
60.
So we got a range between 67 and 70. Overall, water temperature cooler than our air temperature. Kind of important. Okay? That's going to lead us right to, we're going to skip down to one then. Who got dissolved oxygen? What do we get for DO?
Is that about 6, maybe 7 to 8?
6 to 8 parts per million. Did anybody get anything out of that range? She said we took our DO reading in a riffle. And a riffle again is where water is mixing and turning and flowing. Could that impact how much dissolved oxygen is in that water? Why? Because it's mixing with the air. pH answers. 6. Anybody get anything different than 6? 6. Slightly basic or slightly acidic? Slightly acidic. Looking good so far. All right. Let's go through these categories here then. Scientists will tell you anything between, wait, on your data sheets it actually gives you a smiley range for pH. What's the smiley face range for pH?
Frowny to frowny.
Oh, it goes from, and close to 7 is actually pretty good. Anything between 6 and 8 on a pH scale is actually really good for most critters. So on our pH, how does our stream rate?
Smiley face.
Smiley face. Dissolved oxygen. Scientists will tell you anything above 6 parts per million is going to be great for critters to survive. How did we do on our DO? Turbidity, we didn't ask yet. Turbidity had 3 choices. Not good, okay, great. How do we rate?
Much clearer when we got there than when we left.
Why?
Because we churned it up.
We churned it up. So when we got there, what would you call it?
Smiley face.
Smiley face. Stream buffer. This is the area away from the water, and I think on your answer sheets it says 20 feet away from the water. And it was either impervious surfaces and gravel and mud and no plants, some plants there, or a whole lot of different kinds of plants. What would we call our stream buffer zone?
Smiley.
Everybody okay with our smiley face? Looking good. I'm going to skip down to the benthic area, the stream bottom. Your 3 choices were all silt and sediment and murk, or a mix of rock and gravel with a little bit of sediment, or a big mix of clear gravel with lots of habitat and spaces. What's our bottom?
Yeah.
Stream bank. Lots of signs of erosion, no signs of erosion, someplace in the middle. Before I get to that, did anybody notice what's the difference between taxa 1, taxa 2, and taxa 3? It's written out on those identifying sheets.
Ability to survive.
What's
The
that?
amount of pollution that they can handle and survive in.
The amount of pollution they can tolerate. Taxa 3 critters, I like to consider them the slobs in the macroinvertebrate world. They can handle a lot of pollution, no big deal. Taxa 2 critters, a little bit. And the taxa 1 critters are the prima donnas. They can't hack a lot of pollution. If there was a lot of pollution in there, you know who would disappear first? Taxa 1 critters. Yep. So, taxa 3, what sorts of taxa 3 critters did we find? Midge fly larvae. They were the bright orange or the bright green, and really tiny. Midge fly larvae. Any other taxa 3? Taxa 2 critters. What taxa 2 critters did we find? Dragonfly larvae. Crayfish.
Clams.
Clams. Taxa 1. Who found some taxa 1 critters?
We found caddis fly.
Loads of caddis fly larvae. Any other? So, if we look at all of our critters, if we consider our biotic indexing, smiley, middle, or frowny face. All right, here's where we put it all together, kids. The last thing on your answer sheet tells you, asks you, looking at all of our indicators and all the data that we gathered, is that stream a healthy habitat? Is it a healthy ecosystem for the things that live there, or not? And how do you know? So I'd like you to take a couple minutes and write your answers out. Remember why we're doing this activity. if you're looking at your science objectives or your language arts objectives, or several others actually, it's using various data sources to put together a persuasive argument. Or in science, it's using various data to come up with a conclusion. And that's what we just did right there. You could take those conclusions, use them back at school for further investigation. You could use them back in your language arts classes as well. But that's how you can very quickly assimilate all the data that there's the danger of running short on time. And if you're going to skimp on any time, don't skimp on this last bit right here, this conclusion, because this is why you're doing the entire investigation, so the kids can gather their information and put their ideas together. Unfortunately, just from my own observations, this is the time, this is the part of the lesson that most schools do skip if they're running late on time, because it's the last one. Ah, dinner's 5 minutes from now, ah, and they go. Don't make that happen. You don't want to skimp on time down at the stream because that's the most fun for the kids. It's hard for me, you know how much I talk already, it's hard for me to skimp on time in the beginning. So I guess my best advice is just watch your time pretty closely so that you do give yourselves time at the end for this sort of wrap up and this sort of conclusion. Because again, that's why the kids are coming after. All right, talking like kids again. All right, kids, when I call your group, you're going to go put your boots back on the rack where your shoes were. Please put them so that the toes are up so the water will drain out of them. Big nets get hung up where you found them. Buckets, clipboards, and little nets go back inside. When I call your group, you're going to put that where it needs to go, and then back inside the classroom where we're going to meet at the tables. Let's have group 4. Take your stuff and get. Group 4, taking the stuff and get. One way to maximize your time at Outdoor Ed, all the discussion we had here in the beginning, like how do we tell if a stream is healthy or not, could totally be done back at school. Before your time at Outdoor Ed. You could actually have your science teachers do it. You could have any other class who wants to do it take time out. That all it takes is for one kid to find a crayfish, and then suddenly everybody goes, wow, and they want to keep looking, and then they're actually going to try to. Another good way to save time, if you can show them examples of what they're looking for back at school before they get here, it saves a lot of time. We have some, you remember those old insect collections, things that are pinned to boards and they show butterflies and moths and things like that. We have things, a couple things similar to that, little vials full of these macroinvertebrates that you could borrow. We can pony them to you, you can show them in your class. Sometimes a much more reliable way to do it, Google Images, macroinvertebrates, stream benthic macroinvertebrates. And you'll get all kinds of pictures of them. I tried to spend an equal amount of time in each group. I tried to circulate between each group, just like you would do in your classroom if you're circulating from lab to lab or table to table. And I tried to find some stuff with each group too, so they had. Summarizing the sequence of what we did, we got everybody here and took attendance. We stated the purpose. And by the way, we have all kinds of enduring understandings and essential questions written out in the paperwork up here if you want to make it really official. We split up in groups and you guys brainstormed what we were going to look for when we were down there. We did a brief equipment discussion question, got the boots, got into groups, checked the groups, walked down. And where did I spend all the time talking about how to do DO and how to do pH and how to take temperature and how to collect critters? And streams can find something right away to prove them that there are things there. Another thing that I like to try a lot, not just in the wintertime, but when we get a big storm event and that water in that particular stream is going very fast and very high, go to a shallower stream. The Springs Trail stream is never more than that deep, so in wintertime or in rain events, it's still a great place to look for critters and the kids can still stay comfortable. As soon as you see one kid just being slightly goofy or unsafe, I would recommend you bring all of them back in and painfully, and take some time to say, you don't go deeper than your ankles. There's no running around here. There's no such thing as pushing or shoving. And if you're screaming and throwing things and falling down, we can't stay here, we'll leave. Because I can't risk one kid. So after we went down the stream, had time to actually gather data, we stopped and gathered everybody up, had time to admire all the critters and finish up collecting all the data that you hadn't collected yet. Did anybody notice what we did before we left the stream?
Equipment check.
Yeah, equipment check. This is one of the things that will lose a lot of equipment, so please just make sure before you leave. I like leaving one adult at the end of the line, getting everybody off the beach, but then stopping and having that adult do a visual sweep. Before you dismiss the kids, summarize.
make them draw some conclusions about the data that they found. Put the nets back, put the equipment back, put the boots back, then you're good to go for the